Hi, I'm Tom Baggio, Senior Solutions Architect at AnyLogic. The following product demonstrations will showcase some of the new features of AnyLogic 7.1, including the cutting-edge GIS capabilities. Let's create a project and get started. I'll name this project AnyLogic GIS Demo. To utilize a map, we'll bring in the GIS map from the presentation palette and place it on the canvas. We at AnyLogic have integrated GIS capabilities into our software to give the user rich and interactive functionality that is ideal for advanced modeling and simulation projects. Here I can pan, zoom, search routes, and more features, all provided by the GIS provider. Let's create a route between two cities and see how this works. I'll search for a point, Chicago. Select that. And then I'll search for Ottawa, Canada. Get rid of the rest. I can now create a route based on these 2 points by right-clicking on Chicago, selecting route from here, and then right-clicking on Ottawa and selecting route to here. The route is automatically created by the map provider based on the actual roads between the points. Elements such as line style, color, line weight can all be altered from the Properties window, like so. Now, let's put something interactive with this route. Next, I'll add a source block to create an agent to move along this route and set an arrival rate of 1 agent per hour. Where do I want the agent to start? I can select from a pull down or simply select from the GeoNode point located on the map. Any of the properties or elements can be adjusted in a source block. As an example, let's change the speed of this object to 70 miles per hour. Now, let's add a move to block with the destination selected as Ottawa from the map. Completing the logic with the sync block, and we're ready to run. Since the software will create an automatic route based on the 2 point, there's no need to have this manual route in our model. So let's remove that so we can get a better view of the objects moving in our model. Now let's run this model. At model runtime, the map is interactive with the simulation, and we can pan and zoom during this time, as well as cache the views that we have for future runtimes if we're offline. Zooming in and speeding up, we can see the agents moving along the route from Chicago to Ottawa. Let's zoom in a little closer. And slow it down. And we'll soon see agents moving across this path. Notice the agents appear to be taking a shortcut on the route. Well, this is only a visual resolution condition, but the actual arrival time and the distance traveled are exactly equal to the reported route. However, we can change the precision of this view by changing the properties of the map to an absolute precision smaller than the default. Let's take a look at how that's done. Currently, the precision is set to 1 kilometer, and we'll set that to something smaller, such as 10 meters. Let's run the model and see the effect. Speeding up, zooming in. And here we see the agents traveling exactly along the roads as they are presented by the map provider. Again, this is only a view precision or resolution change. The actual arrival times and travel distances are not affected by this view change. Now, let's change this slightly and let's look for a destination based on the shortest route. We'll zoom in on Chicago. Locate the Civic Opera House. Convert that to a GIS point. Close that. Now, Civic Opera House is the home of AnyLogic, so let's rename that to AnyLogic. Now let's create some agents for our model, such as an agent that will be traveling in the map and some destination choices. Let's create a person. And let's give some animation to this person. Something that we'll see on the map. Let's create an agent. We'll call that pharmacy. And we'll also give that some animation, such as a retail store. Now, let's search for pharmacies in our map. And here we have a list of pharmacies that were found in our search window of our map object. Let's convert them to the agent pharmacy. Close that. And now let's create a collection from this group of pharmacies, and we'll call that collection pharmacies. So here we have a set of pharmacies within our map. Now let's adjust some properties and elements. I'll start the location at AnyLogic and set the speed of the person to 3.5 miles per hour. Starting location to AnyLogic, and we'll open up the agent and set the person's speed to 3.5 miles per hour. Let's make sure that we're selecting the proper mode of transportation, which in this case is going to be walking or by foot, and we'll play with the choice of the car selection, and that will actually use the street directions, the one-way versus bi-directional, as opposed to the pathways moving along as a pedestrian does. Now we'll search for the nearest pharmacy. using our code completion, control space, I can easily write a quick Java command, move to nearest agent, and we'll specify the collection of pharmacies. Now, let's run the model. I'll slow the time down so we can see the person moving to the nearest pharmacy. And we'll zoom in. And we see them taking the street and walking across to the pharmacy. So let's change this up a bit. Let's get rid of a couple of these pharmacies that are obviously close, and let's recalculate its route. So let's take a quick look, and let's get rid of CVS 3, this pharmacy, and that pharmacy. So these three pharmacies. So we'll do that by going into the collection and removing CVS 3, Walgreens, like so, and this pharmacy here. And we'll certainly take them off of the display so that it is meaningful to the user. Now, let's run this again and see the result. Slowing it down slightly. Let's pause the model. Let's zoom in. And we'll soon see the shortest path on foot going through the various walkways and roadways as well. Let's change the road type to a car, and now we'll see that the path will be adjusted by the type of streets are available to get from A to B. We'll zoom in again. And we'll see that the person who is in a car now will have to obey the road signs of the one-way directions, etc., and avoid any of the walkway path that a pedestrian would normally take. And so we'll see, speed this up a little bit, and we'll arrive at the pharmacy that is nearest to AnyLogic. Now, let's look at the GIS capabilities from a regional perspective versus points on the map. Okay, so let's save this project. Let's close this. Now let's open a population density model. This is a very simple model that shows the potential migration patterns from Illinois to Florida. Let's run this and see what it looks like. And we can see graphical representation of the density of Illinois as well as Florida. And we can see the stocks and flow changing based on a simple rate of change from Illinois to Florida, and we see the density of Illinois, the population density of Illinois decreasing, as well as the population density of Florida increasing. Okay. Now, let's make the story a little more visual so it's easier to understand. So, in this case, let's add a map. We'll zoom in on Illinois and Florida. Okay. Now, let's search for Illinois, but instead, let's search for regions. And let's do the same for Florida. Select Florida, get rid of the rest, close this. So now we have Illinois and Florida on our map. Change the fill color element to dynamic and type in the function lerp color. We'll divide that by 250 to normalize the value of this function from 0 to 1, and we'll change the color from transparent to red. Now let's copy that to Florida, and we'll change its attributes. Let's run this model. And now we'll see the region of Illinois becoming more transparent as the population moves from Illinois to Florida, and Florida becomes more opaque. We can also dynamically change other variables of the region, such as the land area. Let's highlight the land area of Florida. And here we have a static value of land area of Florida at 70,000 square miles. So let's use the map to provide this. So we will type in Florida dot square mile, and the same thing for Illinois. Let's run this again. Let's pause this, and we can see the land area of Illinois and the land area of Florida are now being read in dynamically from the values provided by the map provider for those specific regions. Obviously, the primary purpose of GIS functionality is geared towards supply chain and logistics. So let's take a brief look at a supply chain demo model. AnyLogic provides a large list of example models categorized in various market verticals. We'll go to the supply chain category and select the product delivery model. This will bring the model into our development environment. Running the model, we see trucks moving between factories in red and distribution centers in green, with each factory owning its own fleet of trucks. As before, the map is interactive, allowing capabilities to pan and zoom. Trucks are following the routes defined by the roads provided by the GIS provider, and once again, the capability of changing the view precision so that the truck travels over the displayed route as in the previous examples. The distributor and the factory agents are dynamically populated on the map with the use of an external file, in this case an Excel file. Each of these locations are defined by the city name only and not drawn on the map until runtime, as you can see. You can find the location of this file by clicking on the Excel connectivity icon and determining its location, or you can simply right-click on the project to determine the model launch location. So we have the Excel file here, or I'll right-click on the project, open model folder, and we'll find that file right here. Let's open that file, and we can see that the distributors are city only, and the manufacturing centers are city name only. In addition to the GIS capability, 7.1 has other interesting features that improve model development. Managing units is now explicitly defined versus the need to manage units with functions. A few examples of this are shown here. Using a source block, the time units are selected from a pull down versus a reference to a model time or writing a time function in the command line. Distance and speed are also managed in a similar manner. I can show this with the conveyor block, where we can set the length of the conveyor to be in feet or meters, and the speed of the conveyor is selected from various speeds such as meters per second, feet per minute, feet per second, etc. We're continuing to streamline the modeling environment by making references within your model easy to visualize and manage as well. Agents are automatically referred to within the logic and inherited from the connection, making the coding more generic and portable. No need to define an entity. The agent and its properties are carried throughout the logic. Let's show that here. The wait for products delay refers generically to the agent, which is defined as the order. Need to find a relationship between elements? Simply click on the item. The references are highlighted for an easy way to identify these. In this example, I click on the delay wait for products, and we can see that the function waiting time and the stock products are highlighted as they are referenced within the wait for products delay. And the same is for this example of the C's block take vehicle is referring to the resource block of fleet. Even within the code itself, simply control-click on a command line and you could utilize the linking function to quickly see where your references are made. As an example, we'll bring in a function block from the agent palette and we'll create a code and if I control click, the hyperlink will take me to the reference to generate demand and the parameter center, which are all referencing the function block. These features greatly improve the modeling environment user interface. Thank you for watching this video, and I hope you've enjoyed learning about the exciting and powerful features of AnyLogic. Feel free to contact your local AnyLogic representative to learn more about the value of AnyLogic modeling and simulation software, and stay tuned for more information as we continue to roll out new and exciting features. See you next time.